All right, this is going to be deleted from the notes because we actually need to do that later. We're doing arc length and those problems. All we talked about is arc measure, so let's bounce down here. All right, what is the measure of angle WZX? Measure of angle WZX. So WZX. Remember, W's first, then Z, then X. So that's the order. You start at W, then go to Z, go to X. So we need that measure right here. Well, something we can look at is we got this right here. What's this measure? Well, what's this red thing right here? Remember, this is a linear pair, which is supplementary, which means it adds up to 180. So to find X, I'm just going to do 180 minus 132, and I get 48 degrees. Cool. Next, what do we got? We got this triangle. Triangles. This seems to be a very famous number. Triangles add up to 180. So to find this, we'll call this Y. It's just going to be 180 minus 48 minus 52. So it's going to be 80 degrees because all of the angles must add up to 180. And then here, the last punchline is this angle and this angle. These two brown angles are vertical angles. It's really, they form an X, however you want to think about it. And they are congruent. You cannot forget that, all right? So the measure of angle WZX is just 80 degrees. It's the same thing. All right. So that's how you do that problem. What I like about this one is since we have a linear pair, triangle sum theorem, and vertical angles, these are just random stuff that we're talking about that's going to help us have success in the future in this class. Next one, in the diagram below, angle 1 is congruent to angle 2. So let's just start talking about things before I even look at other stuff. Angle 1 and angle 4. Angle 1 is congruent to angle 4. These are alternate exterior angles. And because these are congruent, since angle 1 is congruent to angle 4, then that forces the lines to be parallel. Line L is parallel to line M. All right, that was the converse of the exterior angles theorem, which is what we talked about in years or units past. All right, so some other things. That means angle 1 is congruent to angle 3 because they're corresponding angles. All right, remember, same relative position. All right, same position. That says same position, and I always spell neighborhood wrong. Is the I before E? No one knows. All right, in this case, they're both in the top left, so angle 1 is congruent to angle 3. And then angle 1 and angle 2 are congruent. Vertical angles. Some more fun facts. But also, angle 2 is congruent to angle 3 as well. So basically, all these angles are congruent to each other. Angle 2 and angle 3 are alternate interior angles. All right. So those are just some fun facts. So which of the following conclusion is not does not have to be true? Well, we already said line B or line L is parallel to line M. We said angle 1 is congruent to angle 3. They're corresponding angles. We said 2 is congruent to 3. They're alternate interior angles. So 3 and 4 don't have to be supplementary. There's cases where they can be, but they don't have to be. All right, because 3 and 4 are vertical angles as well. I could have said that up here. All right, and then we're just going to do a proof as a quick review of proofs. Make sure we're not too rusty. But in this last one, it's saying two lines A and B are parallel, cut by a transversal. So since they're parallel, all these angle relationships we talked about in the past are true. We're going to prove angle 1 is congruent to angle 7. All right. So they're alternate exterior angles, we know that, but we've done proofs like this a bunch of times in the past. Really what I gotta do is, there's a couple ways to do this. What I'm gonna do is I'm gonna just state out something that we know to be true, because remember, it's an alternate exterior angles theorem. We prove theorems to be true. So what I'm gonna apply is this. I'm gonna say angle 1 is congruent to angle 5. All right, angle 1 is congruent to angle 5. And this isn't a theorem, it's the corresponding angles postulate. All right, it's that one right there. Let's just put we'll just draw an arrow. All right, it's the this, instead of saying corresponding angles postulate or CAP, remember we said CAP a bunch of times in the past? Postulates are just accepted as facts. Corresponding angles formed by parallel lines are congruent, CAP. We accept that as facts, so I can say that. And then this is utilizing another theorem we've proven to be true, 5 and 7. I can say, well, angle 5 is congruent to angle 7. And let me cross these out. Now I can say that. Because they're vertical angles. Vertical angles are congruent. We sometimes say vertical angles, sometimes we say vertical angle congruence theorem, whatever it may be. And then realize, since angle 1 is congruent to 5, angle 5 is congruent to angle 7, angle 1 is congruent to angle 7. We've talked about this a lot in the past, but it's the transitive property. Bada bing, bada boom, and that is that.